welcome back to my YT channel. This is again, I'm a singer, Gino Voice, content creator. So we still have one example for enthalpy change of formation. I don't have to give you another example for enthalpy change of combustion. Instead, I will have to add one problem on enthalpy change of formation. Okay? Something like that, mga kapatid. Okay. So here it is, a research based on, what's this? Oh my gosh. University of Michigan. Yes. My source now is University of Michigan sample problem. Okay, it's gonna be like, what's this? Okay, nakakaloka. Diba? Okay. So, hydrogen gas reacts with chlorine gas to produce HCl. Estimate the enthalpy of formation of 1/2 mole of HCl using the average band dissociation energies listed below. Wow. H to H band 432 kilojoules per mole. Chlorine to chlorine band 239 kilojoules per mole. Hydrogen to chlorine bond 457 kilojoules per mole. Okay? Okay, this is a little bit of exciting. Okay, okay, because it's a mixture of three modes. We have the first, you have to do the chemical reaction. Then second, you need to balance the chemical reaction. Third, you need to do the chemical bonding. Okay? So, the first step to do is to identify what kind of chemical reaction. Since obviously this is formation, meaning to say it is a synthesis and combination reaction. Meaning adding two or more elemental constituents or elements or compounds to produce one compound in the product, something like that. Get the point? Okay, it's gonna be more on bonding, chemical bonding really. Okay, so the opposite is the breaking down of the chemical bond, that is enthalpy change of combustion, but we are not concerned for that for now. Okay, so this is the question all about hydrogen gas. This is a little bit tricky, just observe properly by clear visualization. Okay, gas reacts, okay, with chlorine gas, okay. I don't have to put in words, I have to put in a chemical formula so that it will save us time, right? And also the ink and the space of the whiteboard. Okay, so HCl, okay. Okay, now estimate the enthalpy. Okay, so if you meet the word enthalpy in the future examination, so you'll have more scores na talaga because of this discussion, right? Okay, not only for this, but for other enthalpy change of reaction problem solving. Right? I already introduced to you last 3 days ago, 4 days ago, or even last night, right? Okay, enthalpy of formation. Okay, mga kapatid. Okay. Of 1/2 mole. Okay. HCl. Using the average, okay, average bond dissociation. Okay, dissociation. Gahi because that is I. Dissociation. Okay. So it will be pronounced like this. Dissociation energy. Okay. Listed below. Okay. You know, what's funny, because most of us Cebuanos really sound matigas, our tongue is so, sometimes it's so hard. Sometimes most of us cannot pronunciate properly the I and the E, okay, when we do English or even Tagalog languages. And sometimes they will laugh at us. But we can speak spontaneously most of the times in English rather than Tagalog. Though I'm not speaking majority, but few of us or a lot of us also are convenient in speaking in English rather than Tagalog. Okay, because sometimes there's so deep Tagalog that we cannot understand. Just like me, I'm not comfortable in speaking Tagalog that much. I'd rather speak in English rather than Tagalog in other situation or cases because, mabubulol, my tongue will be, masapit siya or whatever. Okay, so that's it. I'm using Deslish, Bisaya plus English. Okay, it's gonna be like that. And for the reason also that I need to use the universal language or the international language adopted all over the world. Okay, which is an English medium of instruction. Okay, mga kapatid. Now we go to the clue for this particular problem. Okay, like this. Okay. Okay, hydrogen chloride gas. This is very common, right? Also in our digestion process. Okay, in the digestive system, right? We need to have the amount of hydrochloric acid for good digestion of the food we intake every day. So this process is very important. Hydrogen gas plus chlorine gas. You cannot just see the hydrogen gas, but it's inside reacting the chlorine gas because we have salt inside our body. Our food is fortified with salt, sodium chloride, that's table salt. And then you put that in the food to taste it good, right? So the chlorine content from sodium chloride will react to the hydrogen present in the water we intake, also daily ala too, in the drink water. Okay, drinking water. So we can manufacture our own digestive acid, which is known hydrochloric acid inside our body. So this is a very important reaction. Hydrogen gas reacts with chlorine gas to produce HCl. So basically, with the question will state like that in the future science examination, whatever, blanc is a digestive acid. Your answer will be hydrochloric acid, automatically. Okay? And there will be a lot of choices. A, sulfuric acid. B, permanganic acid. C, phosphoric acid. D, ganganan. D, hydrochloric acid. So your answer really is hydrochloric acid. Okay? As simple as that. Okay? Digestive acid. And then sometimes also the question will state the common name or the, what do you call this one? The brand name. For example, muriatic acid. What's the equivalent chemical formula for that? It's just the same as hydrochloric acid. Things like that. Okay? So there's a lot. So just research that for your own self. Sometimes the question will be like that. Okay? So ganon siya. Okay. Going back to the problem. Okay, hydrogen gas H2 plus Cl2 is equals to HCl. Okay? Is this a reversible chemical reaction or spontaneous chemical reaction or whatever? How can we describe this reaction? Okay, so we need to solve yet first the enthalpy change of formation in order to identify what kind of reaction is this, right? Mga palangga. Okay, estimate the enthalpy of formations. This is our first clue. Okay, in solving problem, we need to be alert in the hint. HINT, clue, CLUE, like that. We need to identify what's really asked and required in the problem, and that's the time we can picture out by drawing a sketch, a diagram, to help analyze properly what's going to be the process of this particular problem. And then after that, you need to find an appropriate equations and formulas that suitable for your computation and realistic, logical, and then will validate your analysis. Okay, something like that. It's always like that in problem solving. Even though you are not good in mathematics, just like me, I'm not good in math, but if you have really the, the basic foundation how to solve it properly, then you can still get the correct answer even though you don't have a high IQ in math. Okay? Because not all engineers are good in math that much. And I am one of the examples for that. I'm not really that good that much in mathematics. Okay? Like that. So, you get a enthalpy information. Okay? The symbol is delta H F R X. Okay? Like that. So you need also to have mastery, mastery of, having the Sanskrit, what do you call this one? Symbol, variable, code, or acronym, something like that to make you understand quickly, like that. Okay, for example, if you memorize something, then you have to have your own acronym, something like that. Okay, for easy memorization and also for quick, remembering of the formulas and equations. Subscript is very important also, and also the coefficient, something like that. Okay, so it's gonna be like that always in both math and science. Okay, something like that. So this is the chemical reaction that we have now. Hydrogen gas plus chlorine gas, mga palangga, is equal to HCl. So obviously this is not a balance. Okay, we have to balance the chemical reaction. Okay, hydrogen gas, 2 atoms. There's no atoms, put 2 here. Chararat. Okay, ganon. Then, chlorine gas, this is balance. Okay. Take note of your problem. Estimate enthalpy of 1/2 mole HCl. So it's specified in our problem that we need to yield 1/2 mole of HCl. Things like this is a little bit tricky because we have already the reaction here, but the data in our problem specify the exact and specific number of mole that we're trying to produce in our product. So we need 1/2 mole of HCl. Okay, even though we balance the equation in this way, we don't base our solution in this way. We need to adjust our chemical reaction to produce or to yield 1/2 mole of HCl. So I have to remove this 2 and put 1/2 because that is your desire to be obtained. Okay, now balance again. Okay, so 1/2 HCl, 1/2 chlorine. So how can we do 1/2 chlorine? So we need to have here something like this. 1/2, okay, like this. Okay, 1/2, 1/2. Balance that one. It will balance or not? Okay, so it should be 1/2 chlorine. Okay, so we will say like this. We try 1/2 first because we put 1/2 HCl to our product. So let's just put this as X. Again, math. Okay? Let X the unknown atom of hydrogen and chlorine respectively and do it individually. Okay? So again, let's erase first the 1/2 because we need to put X as the unknown atom of each element's hydrogen and chlorine in our chemical reaction. Or hydrogen gas or chlorine gas. Okay, so X, okay, X of hydrogen gas, okay, like that, okay, is equal to 1/2 of HCl. Okay, ganon. So 1/2 ang H, 1/2 ang H ng ari. Okay, so ganon. So since we have 1/2 here, 1/2 wala makadiri-ari, so let X this apikas. Okay, 2X is equals to 1/2. And then 4X is equals to 1. And X is equals to 1/4. Okay? Right? So X is equals to 1/4. Put 1/4 here. Okay? We need to say 1/4 of hydrogen gas. Okay? Like that. Now, chlorine gas. Okay? Mga palangga. So, if we have chlorine in the other side, chlorine is 1/2, and then we have, okay, chlorine, and we have chlorine also, so this is 2X. X is also 1/4. Okay, X is equals to 1/4. Okay, ganon. Then, balance again for the second time. Okay, hydrogen will be 1/2. Okay, like that. So we need to multiply this by 2, but we cannot do that because if you multiply this by 2, it will become 1/2 and it will become 1 also. Okay, so option 1 is not logical. Okay, it's not logical like this. It's gonna be the situation, guys. If we try to discuss something, because this is not very quick scripted or whatever, you need to have options, option 1, option 2, option 3, option 4, especially if you did not solve or if you did not prepare how to do it, just like this. I did not look for the solution, how it is being done. That's why I need to say option 1, option 2, option 3, option 4, like that, for the purpose of discussion only. Okay? So, erase the 1/4 because this might be not valid. Okay? So, in reality, guys, no, doing things like this is really good because, it's not perfection. Okay? It's not perfection, meaning because, if you are dealing with scientific method, scientific research, there's no such experiment or a research that will be successful for the very, very first time. You have to do it several times in order for you to get the correct conclusion of the scientific research or if it is valid or not. Okay, if you ask different chemists and physicists in the 18th century and 17th century, ask them how many times they repeat their experiments. Okay, it will take them a long time to obtain a valid and acceptable and proven and tested scientific research. Okay, or before coming principle, theories, concepts that reflected in the books. So same like this, what I am doing. I did not go directly to the way it's being sold because I did not know in the first place. I know the process, but I need to do the sequence how to do it. Okay? So option 1, option 2. Option 2, let's try another thing here. Okay. We have 1/2 HCl here. Let's do the chemical equilibrium thing. Chemical equilibrium, okay? So we have H on the left side is 2. Okay? 2 times 1 is equals to 2. H in the other side is equals to 1/2. Right? Ganon. Okay. Now, since deficient ang H very early, sa second, deficient siya. So, we need to put X here. Okay? Like that. So, it will become 1/2 times X. Therefore, 2 is equals to 1/2 times X is equals to X over 2. So, therefore, X is equals to 4. Like that. So, X is equals to 4. Okay? So, put the 4 here. Okay? Put the 4 here like that. Okay? Like that. So 4 divided by 2 is equals to 2. Ganon. So 2 HCl. Take note kita. Like this siya guys. Okay. And then, ubalik mo siya sa iyang chemical equation. Okay? This is option 2 ha? Okay. Now, klaro mo kayo, pinanang siya tudaan. Okay, so chlorine, nagunar ko. So chlorine is equals to 2 and chlorine is equals to 2. So balance. Hydrogen 2, balance. Okay? Ganon. Okay? Like that. Ganon siya. Hindi itong mga palangga. Ganon ang mitabo. Okay? So, this is not correct because 2 moles are being inserted here. Instead, we get 1/2 mole of HCl. Option 2 is also not valid. Okay? Now, we go to option 3. Like that. Nakakaloka, di ba? Option 3. Okay. Ganon. Option 3. So how about staying your balancing equation to be like this, but you will just compute 1/2 mole HCl based on the average bond dissociation energy listed below. Okay, you got the point? And then add 1/2, 1/2, 1/2, 1/2, 1/2 like this. Okay? You get the point? Because the ratio, guys, for example, if you have 1/2 HCl here, okay, then if you break HCl, this is option number 3. So HCl will be equal to hydrogen and chlorine bond. And then hydrogen, positive 1 and chlorine negative 1, right? And then bond that together. Okay, that is H and Cl. So your option 3 will be based on chemical bonding, Lewis dot structure. Okay. Chemical bonding, Lewis dot structure. Okay. So, like that. So, how many electrons on the outermost shell of hydrogen in the periodic table? There's only 1. And then this will be bonded completely to chlorine. Okay? So, no excess electrons of hydrogen. Okay? Now, shared to chlorine. Chlorine has 7 electrons in the outermost shell, and the other one is shared. So, it's become only 6. Lone pair or excess electrons not shared. 1, 2, 3, 4, 5, 6, ganon. So it's gonna be like that. Okay? So, HCl. Since you have 1/2 HCl, okay, for this, so you might say also 1/2 of H and 1/2 of chlorine, right? Because this is tantamount to HCl because you break that band. Right? Ganon. Get the point? Okay. Is this valid option number 3? Put 1/2 all. Okay. So I'll say 1/2 HCl, 1/2 chlorine, and 1/2 H2. Ganon. You get the point? So this is now based on the bond energies dissociation. So we will not base on the balanced chemical equation for the reason we are given 1/2 mole HCl as our product. Things like this, okay? Because it's given already in the problem. But if there's no given, so use the balanced chemical equation and then do also the chemical bonding. So we are now in the option 3. Okay, so how can we do this? So go back to the enthalpy information reaction standard formula. Delta H F Rxm is equal to the summation of the enthalpy of formation of the reactant R minus the summation of the enthalpy of formation of the product. Okay, now you have 2 reactants, hydrogen gas and chlorine. So you need to say that is 1/2. Okay, bond HH because it is H2, right? You get the point. And then plus 1/2, and is chlorine to chlorine. Ganon. And this is for reactant. Okay? Ganon yung tabo ang mga kapatid. Okay? Now, on the enthalpy of formation of the product, we have, so product is 1/2 mole and 1/2 H single bond chlorine, like this. Now, this bonding here in the parentheses has its own corresponding enthalpy change of formation, okay, values, okay, delta HF values for hydrogen gas, chlorine gas, and HCl, and you need to find this in the table, okay, in the book, substitute that here, substitute that here, substitute that here, then you can obtain your enthalpy change of formation. Like that. Okay? That's the answer. So, based on my research, I have here, actually, okay, I have here the chuba chuchu. Okay. I have here mga palangga. Okay. I have here, okay. I have here 432 kilojoules per mole, H to H band, substitute here. And then chlorine to chlorine bond, 239, substitute here. And HCl 47, substitute here. Okay, like that. Get the point? Now, you will see to it, guys, that that type of formation will also match to the answer on your reference. Okay, if that is not coinciding to your answer or reference, so that is wrong. Okay, like that. And then or on the examination, if it doesn't fall to the choices A, B, C, D, E, and that is wrong. So probably you are wrong in the number of moles here. Okay, it's in here. Probably in the stoichiometric relationship, you will be wrong. Most of the examination students will fail to balance this perfectly. Okay, something like that. Okay, like that. Because this is really, what do you call this one? This is rare. Because, you know, in reality, we don't have 1/2 mole exist in the atmosphere or in the laboratory. It's not like that. It's no, it's not quantifiable. 0.5 mole. There's no such point something or fraction something in a chemical reaction. But for the purpose of understanding the coverage, they try to trick us out with a fraction product. 1/2 mole of HCl. Ganon. Di ba mga palangga? So, you get the point mga palangga. Okay? Muna yung nahitabo from higayuna. Okay? Nakakaloka. Okay? Muna siya. So, thank you so much for listening for this beautiful for this good topic, which is enthalpy change information. Bye-bye. God bless everybody. See you later. God bless. And you can comment down below in the comment section. And you can click notification bell for some latest updates of I Am a Singer. You can always, diba? Muna siya. So, muna siya itong reaction, ha? Okay. 1/2 like that. Okay, 1/2 mole dito talaga siya. Okay? Ganon. Okay. Then if you try to balance this one, for example, you put this 2. Okay. This is logical because if you put this 2, this one will be 1/1 siya. Right? And then if you put this 1/2, actually this will become 1/2 also here in the total of the reactant. Right? So it will be balanced. Okay, ganun siya. Okay, so 1/2 H and 1/2 chlorine. Okay, split mo din mo siya, guys, ng HCl. Okay, ganon. Okay, ganon na siya, guys. Okay, pero kung 1 mole siya, guys, kana siya, 1 mole HCl, i-adjust na mo siya diri ang HCl also. Okay, get the point? So dito na siya 1/2. Puro siya 1. Okay? Kaloka. Ganon. Diba? Kaloka. So, muna siya nagtabo. Thank you so much. Bye-bye. God bless everybody.